Hi guys, I'm Suraj. Today we are gonna design a spur gear train. This is a project for Skyfi Labs. So let's begin. First, let's go to the design menu. Then let's go to spur gear section. So now we have the icon here. So we'll select two gears. One is 20 teeth and another one is 40 teeth. And okay, the desired gear ratio is 2. So let's calculate. We want to transfer 3.5 kilowatt of power at 120 rpm. So let's calculate for design compliance, and it's showing design compliance, so let's click OK. So now we have two gears. Yes guys, now we have it. So now let me color these two gears. Let's go to appearance menu. I'm gonna give it which color? Orange. Okay, let's go with orange. Now we have to design a shaft, so I'm going to shaft menu. So the shaft is made in the form of sections, so you can see here. So the middle section is made a bit thick, larger, so that it can transfer the torque. So I'm gonna click OK. This shaft is for the smaller gear. Similarly, let me make another shaft for the larger gear. Now here the middle section let me increase the size of the diameter of the shaft of this middle section. I'll give 128 mm, and now we have the shaft as well. Okay, now after making this shaft, let us align this constraint. Select the center line, then go to here, spur gear, origin, z-axis. Okay, now this has been aligned. Click apply. Now let me flush it. Output minus 70 mm, and then okay. Similarly, let me do the same thing for this one as well. Okay, let's go to assembly, constraint, select the center line, then z-axis. Okay, first let me align the shaft. Okay, free to rotate. Let me rotate it. Okay, now it looks perfect. Now again, let's go to constraint, select the center line, select the z-axis. Yeah, perfect. Apply. Now let us flush this. Select this section, select this section, minus 70 mm. Yeah, perfect. Now let me color these two shafts. Go to appearance. Which color should I give? Yes, yellow would do it. Okay. Yeah. Now we have to give sacrificial keys. So I'll go to design, key, let me select the sections. Okay, I'll select reference plane. This is my reference plane. Then this is another plane. Okay, this is radial reference. Okay, now I have the key. You can also calculate for, let's calculate this design compliance for 3.5 kilowatt at 60 rpm. So calculate. The design shows design compliance. Okay, let me click OK, and you have the key. Okay, now similarly let me do for this gear as well. Key, select the section, give it a reference plane, then select this, then again radial reference. Okay, selected. Let me increase the size of the key. Okay, then let's go for calculation. 3.5 kilowatt at 120 rpm. So let's calculate. Yeah, it shows design compliance. Okay, so we have done our sacrificial keys. So let's color these keys. Which color should I give? Let me color it blue. Yeah, okay, let me color it blue. Appearance, blue. Okay, now after giving the key, let's go for bearings. I'm gonna click on bearing. Let me give the dimension 18 to 22. Let me select cylindrical face. Go for ball bearing category. Ball bearing categories. Now let me select this one, JISB. Okay, I'm gonna click OK. Okay, you have bearing. Now let us mate this section of the bearing with the shaft this side. So for that, first let us go for constraint. Select the center line of the bearing. It's already done. We go to constraint and select this section. Then let me select this one. Yes. Okay. So now let me select some more bearings. Copy, then paste here, another one here, another one here. Okay, let me repeat this. Okay, go to assembly, constraint, align them, First, select the center line. Select the center line. Okay, apply. Just flush it. This one over here. It was not done properly. Do it again. This. Yes. Okay. Again, similarly, let me do for this. The line, and let's mate it. Select this section. And select this section. Yes. Okay. Let me do similarly for this one. Constraint. Center line, center line. Now let's mate it. Select this section, then select it's not done properly. Again we'll do constraint, select this section, then let me go here, select this section, what's the problem? Let me do it again. Yes. Yes, now I've done it proper. Now let me color these bearings. Select, go to appearance, and which one? I'll color it green. Yes. Okay. Now our gate train is ready. Now let me give it a bearing housing. So let's go to place imported CAD files. Okay, bearing housing is here. Open. We place the bearing housing one over here, another over here. Okay, let's begin. So now we have to place this bearing housing. Let's place this bearing housing near the gate train. Just click on this. Free to rotate and align a bit. Similarly, let us do for the same this one. Free to rotate, align this. Now let's go to constraint. Select the center line and select this section. Then select this outer section. Yes, you have aligned. Now similarly, let's do for this one as well. Let me flush it. Select this section and this section. Okay. Now let me do for this. Look here guys, it can rotate like this because it's not constrained. So let me constrain this section as well. Select this and select this. Okay. Now we have completely constrained this side of the gate train. Similarly, let's do the same thing over this side. Go to constraints, select this. Okay. Let me flush it. Select this section, then this section. Okay. Let me similarly do for this as well. Constraint, select this section, then this section. Okay. Okay, now the gate train is constrained. So this won't rotate. Now first let me ground these two sections. Go here, grounded. This section also grounded. Let me select these two. Flexible. Now look. Now we can rotate this gear. Now let me give it spline to transfer power. Go to design, go to parallel spline, select this section. We want spline over here. So let's go for calculation. We have to transfer 3.5 kilowatt power at 60 rpm. So we are doing calculation. Let's give it length design. So it's gonna show us how much length the spline is going to be. Now let me calculate. It shows design compliance. Here the factor of safety is 1. Let me increase this factor of safety for 2. Then let's try calculate. Yeah, it's going the length 50 mm. Then let me select another section reference. It's showing the length of the spline. Now okay, so guys, we got the spline. Similarly, let's do for this section as well. Go to spline, select this, go for calculation. 3.5 kilowatt, 120 rpm. Design calculation for length, factor of safety 2. Calculate. It's showing 28 mm. Okay, select the reference plane now. Okay. Okay guys, now the spline you can see in this section as well. Just for appearance, let me also color this. Which color should I give? Red. Yeah, the red looks nice. See, now by using the spline we can rotate it. The gear, we are transferring 3.5 kilowatt of power. The bigger gear is rotating at 60 rpm. The smaller one is 120. So that's it guys. Thank you.